The final part of this lesson is going to take us both back to Algebra 1 days and is looking ahead for Algebra 2. This is a concept you will go into much more detail with in Algebra 2, and it's going to draw heavily on some factoring information you learned in Algebra 1. So we have to take a step back and we have to talk about some special factoring pairs you may have learned about. When we have something like the quantity a plus b squared and a minus b squared, you may have learned a shortcut that they always expand out into a squared plus twice the product of the two plus the square of the last, or the square of the first minus twice the product of the two and the square of the last. You may not have, and you may have just always gone back to remembering that a quantity squared means two things being multiplied and gone ahead and used FOIL, first, outer, inner, last, or double distributive, depending on who your teacher was. Let's just look for a minute. Factoring and FOILing are opposite operations. And if we understand how this quantity squared is formed, it's going to help us in the next part of the lesson. So let's go ahead and expand something very simple like w plus 3 squared. So first two terms, w squared. Outside terms, 3w. Inside terms, 3w. Last terms. And I'm going to write 3 squared just for a minute. Outside and inside always combine. So w squared plus, and I'm going to combine them this way, 2 times 3w plus 3 squared. Now we would go on to write w squared plus 6w plus 9. And we would call our answer done. But this line right here is the one I really want you to think about. Now, if I'm going to factor, if you remember your factoring, we look at the last term and we say, well, what factors of 16 are going to add or subtract to make 8? And we say, well, if I were going to change this into 4 terms, because remember, that's where it came from, 4 terms that combined into 1, what could I do? Well, obviously, minus 4y and minus 4y. If you think about this 16, that's really 4 squared. But when we are factoring, we group these two, we group these two, we look for greatest common factor, y. I pull out a y minus 4. I'm going to pull it out a negative 4. That leaves me y minus 4. Greatest common factor, y minus 4, y minus 4. And we know that simplifies into y minus 4, the quantity squared. Now hopefully you were all noticing that there were 2 of these, and this was a perfect square, and so of course it was going to end up meeting one of those special factoring pairs. Now, one more step. What would be needed to package this back here? Well, the back term in all of these has been the square root of the expanded term. The b squared goes to the b. So here, the square root of 25 is 5. And if I take x minus 5, the quantity squared, and expand it out, I will get that trinomial. What does all of that have to do with circles? We're getting there. One more step. Not all equations are perfect setups. Clearly 7 isn't a perfect square. But the beauty of numbers is I can force them to do and be anything I want. So, very systematic. Number 1, we're going to add or subtract the constant away. So I'm going to have x squared plus 6x equals 7. I'm going to move that constant. I'm going to take half of the x term, I'm going to square it, and I'm going to add that number to both sides. Golden rule of algebra, what I do to one side, I must do to the other. So when I write this, I usually do this. I leave that blank. I physically write that blank to remind myself. I'm going to take half of this term. Why is it half? Remember, this 2, I have to undo that 2. Half is 3, square 3, and I'm going to literally write 3 squared right there, not 9, and you'll see why in a minute. This, now, without thinking, because I built it so, will factor into this. And so I can take the square root of the first term, the sign in the middle, and the square root of the second term, the quantity squared. That will be equal to 7 plus 9, which is 16. So I've just turned something that wasn't a nice factoring pair into something that was. Now, algebraically, we could now solve for x, which is cool. If I'm going to take and undo a square, I'm going to take a square root of both sides. When I take the square root, remember plus and minus, which means I get 2 possible answers. X plus 3 equals 4, or x plus 3 equals negative 4. You might remember this from algebra. Subtract 3, x equals 1, or subtract 3, x equals negative 7. That's the algebra side. What does this have to do with circles? Let's go to the next example that actually has to do with circles. This is a circle, but it's not in that vertex form where we can clearly see HK and the radius, but we can make it be that. So we're going to get those constants away first, then we're going to group our x terms with parentheses, and we're going to leave those spaces. So I'm going to move the 9 and do the grouping. So I'm going to have x squared minus 4x plus, leave that blank, plus y squared minus 6y plus, leave a blank, equals negative 9. Remember, I moved the 9, plus a blank, plus a blank. First blank, half of this term, which is 2, square it, add it to this side. What I do to one side, have to do to the other. Half of this term, I don't care about the sign, is 3, square it, add it to both sides. Now, again, the whole point of doing this is without thinking, without worry. I know that this packages back up into the square root, this sign, the square root, quantity squared, plus the square root, this sign, square root, quantity squared, is equal to negative 9 plus 4 plus 9 equals 4. So my center and radius, my center is at 2, 3, and my radius is 2. It's a pretty powerful formula. Let's try one more example. We are going to do this example in class because it is a pretty elaborate, because if you notice, the coefficient of the x squared isn't 1, and the coefficient here isn't 1. So there's an extra step. So we'll talk about that one in class. But we can handle this one in the video. So I'm going to have x squared minus 4x plus a blank. It's going to be my first thing, plus y squared plus 2y plus that blank. Move the 4, negative 4 plus a blank plus a blank. Half of 4 squared, half of 2 squared. Always remember to add them to both sides. This packages up into x minus 2, the quantity squared. The next one packages up into x plus 1, the quantity squared, is equal to minus 4 plus 1. And so my center is at 2, negative 1. Remember, minus a minus. The square root of 1 is 1. So that is completing the square. If you do it in that systematic way, I think you'll find that it's a pretty doable process, even though it looks kind of big and scary. So good luck on your homework. And again, we will cover number 2 in class. Have fun.